So this is a completely regular and normal website, and I'm going to try to browse this website. Let's click on the home button. While clicking the home button, I notice that I get infected. I get redirected to a completely different site, and now there's malware downloading on my computer. Maybe it was just bad luck. Let's try refreshing this website and see if there's anything different. So now I try refreshing this completely normal and website that I use every single day to look at blogs. But again, after refreshing, I get redirected to the same malicious page, and now there's more malware downloading. Well, let's try, maybe the home button was programmed differently, so let's look at what it's actually doing. And after I inspect the home button and see what it's doing, it's taking me to /. The redirection is actually not in the source code. So how is this forwarding my requests to a completely different server? How is it responding from a different server? Upon clicking the home button again, I notice that I keep getting redirected to this malicious website. And now there's even more garbage downloaded onto my computer.
So when this regular legitimate user is browsing their regular blog website, how are they automatically redirected to a malicious website and have downloaded malware? Disclaimer, this video is intentionally oversimplified for clarity and ease of understanding, so not everything presented is 100% accurate. The web server in this example has other vulnerabilities that an attacker exploits, but the primary focus here is on HTTP request smuggling. Let's look into this with some diagrams. So we have our malicious user, which is me, and I send a request 1. I send this request with a regular start pattern and a regular end pattern, but in the middle I actually send in another end to this request. When the front-end server receives this, it actually can't understand the end, so it doesn't process it, but it processes the regular start and the normal end. And what it does is it bundles everything in between, and it just thinks of it as regular data. So then this front-end server sends this to the backend server. The backend server actually is able to understand this different style of end that I sent. So what does it do? It uses the regular start, but to end this request, it uses the different style of end that I sent. So now what happens with the data after that? This one right here. Well, since the request is already ended, it actually takes this data doesn't really mean anything. So it actually puts it in its queue to respond to the next user. So the data from here is actually sent to the queue. But whatever we sent here, it's responded that to request 1. So now what happens when we have another user make a legitimate request? This is the regular user that we saw in the previous video. So the regular user doesn't send anything too crazy. It has a normal start and a normal end. When the front-end server processes this, it just goes straight away, and the regular starts and the stops, they're processed normally from the front-end server. But what happens when this is sent to the backend server? The backend server already has something in its queue, and it's not really ready to send this out yet. So the normal start gets actually appended to the end of the previous request, and then we have the end of this request gets sent here normally. The backend server just thinks of the everything in between as garbage because it can't process whatever this is. So it thinks of that as garbage, and the regular start that it had here went from there, and then it added its malicious stuff, and then the second user's request was used to end this request. So now this backend request 2 is sent back to normal user request 2. So as you can see, we have a normal user request 1 that could control the start, that can control the malicious stuff, and then when another user sends a request, it actually ends off the request in queue and it sends back. So we have our first user with our first request that can control the response that user 2 gets because it was able to add stuff in its queue. And this happens because the front-end server and the back-end server, they don't agree together on what protocols they're using and what they're using to start and stop these requests, which allows attackers to control the queue and change the way the servers respond to these requests. So what we saw earlier was the theory aspect of it, and now I'll be going through a little bit of the practical demonstration. So if you recall from the first request that we sent, there is a header that the front-end request understands, and that determines the body of the request and everything we sent inside of it. So over here, that is the content length header. The front end understands this content length header. So when we specify that to 129, that's 129 bytes that it considers to be part of the request, and then it terminates this request. So if we look at everything that is in the body after the last header of this request, you can see that it is 129 bytes over here. So what the front end does is it basically sends everything inside here without trying too hard to understand what it is, and then it comes to the backend. But when it hits the backend is actually capable of processing this other header here called transfer encoding. And transfer encoding header basically indicates that everything will be sent in chunks. The 0 here actually, it basically means that the request here is ended and everything is done. So the the back end here, what it's going to do is it's going to consider this as the end of the first request, and everything else after that it's actually going to put in its queue to respond to the next request. And since you notice that there is no carriage return or new line character at the end here, everything that the next request sends gets appended here. So if you look at the next request, the first field is a get, which is the parameter, HTTP parameter, and then just the protocol and stuff like that. So it's basically going to append that over here, and then the rest will just be a bunch of gibberish. And since we specify the content length is 10, it's only going to take the first few bytes of this request and then respond to pretty much what we're asking for here. So let's look at this in practice. We're going to send this request in as the malicious user. So let's hit send, and then we're going to have the innocent person here send their request. And when they send this request, you can see the response here is actually a redirection, which is indicated by the 302 found, and they're going to get redirected to what we mentioned here, which was anything. So now if we change this to, let's just say we do cyberc.com, for example, we would have to change this field as well because now the request has increased. So let's change it to 132, and let's hit send. And now let's have the regular user send their request. And look, now the regular user is redirected to our website. So I'll kind of also go over what the first request is and what the second request is. So the first request here, this is just in the backend server actually. So the backend server will terminate the request here, and pretty much it will respond to everything that is in here. So this is the backend server responds to this as the first response, and then it pretty much responds to this as the second response. Since the content length is 10, it's actually going to respond to the first 10 bytes. So let's take a look at what that is. So it's actually just going to be that much, but it won't really process much of that. It's a get request anyways, so it's just going to respond to this and redirect us to cyberc.com.